Hello everyone, this is Somrita and welcome to my YouTube channel. My goal is to educate people with chemistry and the basics of research. My goal is to help the budding researchers and all of the researchers, the common problems we face in research, as well as I want to teach chemistry to the undergrad students so that they can help themselves to pursue a career in chemistry. So uh, let me introduce myself briefly. Let me share the screen. I hope you can see the screen now. So my very first topic I would like to teach is NMR spectroscopy in organic synthetic research. Before I go into details, I would like to say a few words about myself. I do possess a PhD degree in chemistry. After that, I have pursued several years of postdoctoral experience uh, in different areas of chemistry. For details, you can visit my LinkedIn, Google Scholar, and ResearchGate profile to see the details of my research and my about myself. And if you have any question, you can always ask me in the comment section. And now I would like to start my video without any delay. So NMR spectroscopy, this is a very important topic in organic chemistry, but the spectroscopically theoretical thing which we study in the book for undergrad, uh, that is a little different thing. I am not going into details on that in this video. I will make separate videos for that aspect. This is mainly focused for people in research. How do they analyze the NMR spectroscopy? This is a very important characterizing technique. Whenever people make new organic synthetic molecules, it's essential to characterize them with NMR. So I thought I should make a fundamental video on that. How do people characterize their molecules with NMR? So let's start the video. So what is the full form of NMR? That is nuclear magnetic resonance. So protons and neutrons of an atom make the atomic nuclei spin around the own nuclear axis. As you can see in this figure, this is nuclear charge and it spins around its own nuclear axis. So this generates a magnetic dipole around the nuclear axis. And each nuclei possesses a unique spin angular momentum associated with this spinning. So the resultant of all the angular momentum of all nuclei within an atom is termed as the total nuclear spin. So a nucleus has 2I plus 1 spin states. I is the spin quantum number. So if the total number of protons and neutrons is odd, then I will be half integral, like 1 is 13C, etc. If the total number of protons and neutrons is even, I will be 0 or integral. If both protons and neutrons are even, I would be 0. And in this case, that will be definitely NMR inactive. So magnetic properties occur within the nuclei with odd atomic number and odd mass number, or odd atomic number and even mass number, and even atomic number and odd mass number. So NMR active nuclei should possess the angular momentum and magnetic moment associated with that. So NMR is best observed with the nucleus having spin quantum number half. Two best examples are 1H and 13C. That is why in organic synthetic research, we mostly deal with proton NMR and 13C NMR. Any new molecule or known molecule, you just make it and you characterize it with proton NMR and 13C NMR. So how do you do that? I'm going to discuss them in point by point so that you can yourself master this technique. How do you NMR, how do you analyze these NMR signals? You make a solution, you take the spectra, and then you are seeing some signals and you are, oh, how do I analyze it? It's so difficult. And you can teach yourself. I will teach you how to analyze it. So there are several points. I'll discuss one by one in my videos. So point one is the total number of peaks in NMR signal. First thing you have to do is to characterize, to identify the different types of protons present within the molecule. What do we mean by different types of molecules? That means their chemical environments are different, they are distinct. Like in this example, you can see there are 6 different protons present. So how do you do that? So let's say this is the one. I have numbered all the different types of protons here. This is one. This is associated with the carboxylic acid. And this is 2. So here there are 2 protons attached with this carbon, and there is attached to another carbon and another CO2H group. So this has a distinct chemical environment. Similarly, 3 has a different chemical environment, but you can see 4 and 4, they have similar chemical environment. Similarly, 5, they have similar chemical environment, and 6, it has a distinct chemical environments. So there are 6 different types of present within this molecule. So we'll expect 6 different peaks associated with its NMR signal. Let me go to the next examples. As you can see here in this structure, I have not made it very complicated. These are easy structures. So as you can see, there are 4 different types of proton attached with the structure. This is one, it is attached to a carbon which is attached to bromine, and this is attached to another carbon which is attached to a chlorine. Similarly, 2 and 3, they are almost similar, but they are not exactly similar. Because here you can see 2 is attached to a carbon which is attached to bromine, and 3 is attached to a carbon which is attached to a chlorine. Similarly, 4 is attached to CF3. Obviously, its chemical environment is very different from the others. So you can expect 4 different peaks associated with its NMR. Now let's go to this example. As you can see, there are 1, 2, 3, 4, 5, 6. There are 6 different types of protons associated with this structure. So we will expect 6 different peaks associated with its NMR. Now, let's go to this structure. This is a little complicated. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 different types of protons. You see their environment are all different. So we will expect 9 different peaks associated with its NMR. Now, this is the most complicated structure. You can see like so many rings are fused together. So in the practical research, you will get complicated NMR like this. So I have made this complicated structure. You can see there are 13 different types of protons. Like, see, there are one, they have similar environment, two, they have similar environment, and then three, it is distinct, four is distinct, five is distinct, then there are two, six, two, seven, and then eight, and then nine. And I think I have forgot to mark this one. I'm sorry for that. There will be another proton associated with this, and then 10, 11, 12, and then 13. So there are total 14 different types of proton associated with this structure. And let me go back. So we can expect 14 different peaks associated with its NMR. It's complicated, right? Yeah, so but in real research, you will get complicated structure like this. So you have to practice to from different structures, how to identify the different types of protons so that you can get an idea how many how many signals you are going to get, how many different peaks you are going to get within an NMR. So this is my very first video, and I will teach you in the next videos how to characterize a NMR signal. I will teach you all the basics so you can do it by yourself. So up to this, what I have taught, if you have any question, you can write me in the comment sections. I'll try to answer all of them. And thank you, and please subscribe to my channel. I would like to teach more and more. Thank you.